Okay, now we're looking at an example that's a little bit more complicated, okay? Why is it more complicated? Okay, we first look at the plus sign. So we're adding here, we're adding scientific notation, numbers that are in scientific notation, okay? One thing we notice is, you'll notice the powers there are not really the same like we've had before in the examples before. This one's to the power 8, the other one is to the power 5, right? So the right way to go here is, first, before we understand what we need to do is, we need to get these powers to be the same. We need to manipulate them in such a way that they're the same, okay? But there's one thing that we need to forget, okay? We need to remember. If we increase the exponent, so we're taking the exponent to the right, that means our coefficient is going to go to the left, okay? So it's the reciprocal of the other, basically, okay? If we're going to the right with the exponent, so we're increasing it, that means the coefficient is going to decrease, okay? And the other way around, if we're going to the left, the coefficient is gonna increase, okay? So let's look at this, okay? How are we going to do this? Because of what I've said, if we change this one to be 10 to the power 5, we're not going to win, because the coefficient is going to just get bigger, because the comma is going to move constantly to the right, and we'll end up with 2000. And 2000 is not in scientific notation, okay? So our best bet is to work with this, okay? If we work with this, if we shift the exponent to the right, okay, exponent, if we increase it, that means the coefficient is gonna decrease, okay? The coefficient is gonna decrease. That's the, no, that's not the coefficient. That's the coefficient. That's the one that's gonna decrease. The exponent is gonna increase, okay? That seems like the case that we need to do now, okay? What we need to do is, I will show you for us to get into this. If we have 3 here, so I'm just gonna write 3 in blue, okay? The comma is here at the moment. It's basically 3.0, okay? That's the comma at the moment, okay? So now we need to get this power to be 8. So that means we need to plus 3. We need to increase this power 5 by 3 to get to 8, okay? So for us to do that, we're moving to the right. We're moving to the right. That means this comma is going to shift to the left, okay? So let's shift it 3 times to the left. It's right here at the moment. We shift 1 time, it's going to be 0.3. We shift 2 times, it's going to be 0.03. We shift 3 times, it's going to be 0.003, okay? 0.003. Okay, sorry, my thing is not so clear there. So that's the number we have, okay? I'm just going to rewrite that number in a much neater way. I was just showing how the comma moves here. So if I write this number, so that means we will have my thing is not moving now. I'm gonna try that one. Okay, so that means, what do we have then? Okay, what do we have? We will have 0.003. I use black. 0.003. all because we've shifted this comma from here, shifted this comma 1, 2, 3. That comma is there. Okay, that's how we got to that. We'll multiply this by 10 to the power 8 now, okay? We shifted that by 3. We increased it by 3. This one went down by 3. That's just because that's the rule that we need to remember. Okay, and we still have our plus. We'll carry on 2 to the times 10 to the power 8. It's really easy now in this case, okay? What we've been able to do, we've been able to get those to be the same. That means now we're in the all clear to add these two, okay? So that means we will have 2003 times 10 to the power 8. Okay, that's our final. Okay, we've got a much more complicated sum here, okay? what we need to look at, we've got the divide sign. So what we'll do first is we'll work with the numerator and then we'll work with the denominator, okay? Because that's just how things are. So we can see there that this is not the same as that, as well as if we look at the denominator, that's not the same. So that means we just need to do a bit of fancy footwork before we get into the sum, okay? Okay, we're going to talk about my choice first, right? If I look at these two, okay, I look at the power here, I look at the power, it's 23, I've got 22. The question is, which one do I work with, okay? If I shift this down, if you remember, if this exponent of 23 goes down, that means the coefficient, which is 4.35, is going to go up, which means we'll have 40 now. We'll shift this comma from there to there, and we don't want to do that. Remember, 40 is not in scientific notation, it's more than 10. Okay, so where we have a chance of doing is, if we take this, if we go up with this, if we increase it, that means the coefficient is going to go down. So that means this comma here is going to shift here and we'll have 0.15. Okay, does that make sense? So that's the first thing that I need to understand and I need to gauge. Which power or which term do I change? Okay, so we're going to do that now. Okay, so what do I have now in the numerator? I'm just going to remove that guy. Okay, what I have in the numerator, then I will have 4.35 times 10 to the power 23. I leave that as is, plus, what am I going to have? I'm going to shift this 22 up. When I take it up, the coefficient must come down. So that means that comma is going to shift. It's going to be 0.15. I'm only shifting it one page because I need to be times 10 to the power 23. Okay, that's the numerator. Okay, so in the same light, I need to now look at the denominator, okay? Numerator is done. I've done a great job there. My powers are the same. My powers are the same. I'm good when my powers are the same. Right, so what I'm going to do next is I'm going to look at my numerator, my denominator, okay? With my denominator, same story. If I shift this 15, I shift it down, I go left, that means I'm going to have 20 over there. Because once I go left, the comma shifts to the right. So I'll have from 2 to 20. The minute I work with 20, I'm in trouble because I'm not in scientific form anymore, in scientific notation. But if I take this up, so I take this to the power 15, I'm going to shift this. This is going to shift to the left. The comma is going to shift to the left. So I'm going to have negative 0.5. Exactly what I want. I'm still working within scientific notation, which is really, really important. Okay, so let's do that. What am I going to have then? Knowing what I know, what I'm going to have in the denominator is I'm going to leave 2 times 10 to the power 15 minus, now I'm going to shift this because I only need 1, so it's going to be 0.5 times 10 to the power 15. Okay, from here, Bob is your uncle, really. That's the same. That's the same. So that means I can just add the numerator and the denominator with ease, really, okay? Just running out of space here. So what am I going to have on top there? 4.35 plus 0.5. So on top, I'm going to have 4.5 times 10 to the 23. And then it's going to be divided by, okay, that's in the denominator. I'm going to have it in 5. I'm going to have 1.5 times 10 to the 15. Okay, so from there, this is really easy to work from there. What we need to work out from there. Okay, so just a continuation. So this is what we have now. This has become very easy. Okay, we've done the hard job. Now we don't have a plus anymore. We just have a divide. We've got a term with one numerator with no pluses. So it's really easy. We've done this before, and I'm gonna do it very quickly. So we're gonna look at that side first. and then we look at this. Okay, so all this is in red. I've got 4.5 divided by 1.5, and then times 10 to the power 23 divide by 10 to the power 15. Okay, that's easy, we've done. Okay, so that first term, the coefficient, if you like, is gonna be 1.5, so 1.53, 4.5, so that means that goes 3 times there, times, remember, because of this divide sign, okay, because of the divide sign, we've got powers of the same base, law number 2 of exponents, we minus the exponent, so that's going to be 10, 23 minus 15, which is really equals to, that would be 8. Okay, so final answer is going to be 3 times 10 to the power 8. That is the final answer. Okay.